guys, this is Mrs. Woodard. I'm here at home, as we all are, and I have a science experiment on sound, which we've been learning about. I've got 3 bottles here, empty glass bottles, and I put different amount of water in each one. This one obviously has the most water, a medium amount, and the least amount of water. And I'm going to make sound with these 3 bottles and have you all observe as scientists and see what happens when I make sound. So the first way I'm going to make sound is by blowing across the top of the bottle. When you do this, it's a little tricky, so if you're doing this at home, you want to experiment and sort of see, you want to kind of blow across the top but slight angle downwards. So okay, so that's the one with the most water and the least air. Now I have the one with the medium amount of water and medium amount of air. And then this one has the least amount of water and the most amount of air. Okay, and by the way, that took me a lot of practice till I could do it like that, so if you're doing it at home, don't get frustrated. It takes a long time until you can figure out what angle to do to make the sound happen. Otherwise, if you don't have the right angle, it just sounds like random air. You know, that's not it. You've got to... So think about which one of those has the lowest pitch and which has the highest pitch. So let me do it again in this order. The most water and least air. Medium. And the least water and most air. Okay, so think about which one of those had the lowest pitch and the highest pitch. You might want to pause to think about that. You could also rewind it. Just take a moment to think about that. All right, so do we agree that this one with the most water and least air makes a higher pitch, and this one with the least water and most air makes a lower pitch? Yeah. Okay, so now I'm going to do something a little different. I'm going to make a sound in a different way. This time I'm going to take this and I'm going to tap on the bottle. What? Listen to that again. Okay, so think about which one was the lowest and the highest pitch here. Okay, so what did you decide? Let's compare just this one with the most water and least air to this one with the least water and most air. Yeah, this one is lower and this one is higher. And is that the same as when we were blowing? Let's see. So when we tap, low, high. When we blow, high, low. So it's the opposite. So think about why that is. What is happening? So think about what is sound. Sound is vibrating matter. Okay, so it could be vibrating solid, liquid, or gas, or I suppose maybe plasma. I don't really know. So what is actually vibrating when I blow? And what is actually vibrating when I tap? And also think about how we've learned that when the air or water, whatever's vibrating, when it has a larger space to vibrate in, then that same amount of energy, if it has a longer space to vibrate in, then it's going to make I made that even longer than the space I gave myself. That's going to make a very long sound wave, and longer is lower. It's slower vibrating and it's lower. Now, if you have that same amount of energy vibrating in a smaller space, then that's going to be higher because it's going to be faster. Because if you had this long amount of space here that you have here, that same amount of time, you'd have many vibrations. And so that would be a higher pitch sound. So when we tap, this is lower, this is higher. So what is longer and what is smaller in each of these bottles that's making those pitches be different? That's right, it's the water. There's a long amount of water here. So that same energy that I'm doing when I'm tapping is making the water vibrate. And when I tap this, the water is also vibrating, but it's vibrating a lot faster because that same amount of energy has only a small space to go in. So it has to go faster in there. So when I blow, it's the air that's vibrating. So this time, this one is low and slow because there's a long amount of space to vibrate. And this one is short, and so it's vibrating faster. So that's the difference. In fact, if we look at it this way, if we think about it sideways, when I blow, there's always the way from here to here, which is some space for that to vibrate in. So that's making like a very long vibration. If you turn your head sideways, well, this is messy looking because I'm trying to draw on a bottle, but if you turn your head sideways, let me see if I put this behind it, if you can see it a little better. Yeah, you can't really see that well, but that would be a long space that could vibrate in, whereas when I tap it, is this short space. It's got to vibrate in a smaller space, so that is like this. So maybe you can see that here, a very long wave here, a very small wave here if you're looking at it sideways. So if you turn your head sideways, you can see that would be a very small wave and a long wave. And the same would be opposite here on this one. From here to here, when the water vibrates, if you turn your head sideways, you would see that this would be a very long and low pitch. And this here is a lot shorter. So it is a shorter wavelength and it has a higher pitch. So you can kind of see that there. All right. So I hope that you guys get inspired to do some of your own science experiments at home with sound and tap on also just all kinds of different objects. So, get inspired. For instance, I have some different pieces of pottery that I made here, and I can tap on these different pieces and see what happens. So here's one, and here's another one. Whoa, that sounds very strange. This one's a little differently shaped, but these two are kind of similar shapes, but one is big and one's small. So yeah, that's really cool. This one is higher, and this one is lower. So this applies not just to the water and the air, but to any object. If you tap on it, you're going to get a larger object. It's going to have a lower sound, a lower pitch sound, and a smaller object will have a higher pitch sound because those sound waves, that energy is compressed into a smaller space, making shorter and shorter wavelengths, so there's more of them in a given time, a higher frequency, higher noise. And here it's larger. so it makes a lower vibration, and because it's a long wave, and so it's low and slow, high, small, low, large. All right. So see what you guys can find, and maybe see if you can make a video and upload that onto Google Classroom so that we can see some things you found that make different pitches of sound. All right. Bye, guys.